Python is one of the most widely used and versatile programming languages today. It's known for its simplicity, readability, and powerful capabilities. In this presentation, we'll explore the fundamentals of Python, from basic syntax to advanced applications. By the end, you'll have the skills to become a proficient Python programmer. Python is an excellent language for beginners to learn as it has a gentle learning curve. It's used in a wide range of applications, from web development to data analysis and machine learning. Python's popularity continues to grow, making it a valuable skill to have in today's tech landscape. Python is a popular, high-level programming language known for its clean, readable syntax and powerful capabilities. It's a general-purpose language, meaning it can be used for a wide variety of applications, from web development and data analysis to machine learning and automation. Python is an interpreted language, which means it executes code line by line without the need for compilation. This allows for rapid prototyping and flexible development. Python is also dynamically typed, which gives developers more flexibility in how they write their code. Additionally, Python has a vast ecosystem of libraries and frameworks that extend its functionality, making it a versatile and powerful tool for developers. Python's intuitive and readable syntax makes it easy to learn and write code quickly, allowing developers to focus on solving problems rather than syntax. Python has a vast ecosystem of pre-built libraries and frameworks that provide functionality for web development, data analysis, machine learning, and more, accelerating development. Python code can run on Windows, macOS, Linux, and other platforms, making it a versatile choice for building applications that need to work across different environments. Python's strong data manipulation and visualization capabilities, combined with powerful libraries like NumPy and Pandas, make it a top choice for data science and business analytics. Python has a clean, readable syntax with minimal boilerplate. Whitespace indentation is used to define code blocks, making the structure of programs clear. Python supports common data types like integers, floats, strings, booleans, and lists. Variables can hold values of different types, providing flexibility in your programs. Variables are named storage locations that hold data in Python programs. They allow you to store and manipulate values throughout your code. Python has several core data types, including integers, floating point numbers, strings, and booleans. These fundamental data types form the building blocks of Python programs. We'll explore each of these core types in more detail in the next few slides. Arithmetic operators like plus, dash, asterisk, forward slash, and percent allow you to perform mathematical calculations within expressions. Comparison operators like comma, equals, 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 and equals let you test the relationship between values and create conditional expressions. These comparison operators are essential for control flow statements like if-else. Logical operators like and, or, and not can be used to combine and negate Boolean expressions, enabling complex conditional logic. These operators and expressions are fundamental building blocks of Python programming that allow you to perform a wide range of computations and control the flow of your code. Conditional statements are a core part of programming, allowing us to make decisions and control the flow of our code. If-else statements are the foundation of conditional logic. They execute different blocks of code based on whether a condition is true or false. Comparison operators like comma, equals, 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 and equals allow us to test the relationship between values and create the conditions for if-else statements. These comparison operators are the building blocks we use to construct the Boolean expressions that power our conditional logic. Combining comparison operators with logical operators like and, or, and not enables us to create more sophisticated and nuanced conditional expressions. This allows us to handle a wide variety of scenarios and make our programs more dynamic and responsive. The slide provides an overview of different types of loops in Python programming. Explains how while loops execute a block of code as long as a condition is true, useful for repeating an action until a certain state is reached. Describes how for loops iterate over a sequence like a list or range, allowing you to execute a block of code for each element. Mentions that loops can be nested inside one another, enabling you to iterate over complex data structures and perform multi-dimensional operations. This slide is accompanied by an animation sequence illustrating the concept of iteration through loops. Functions are reusable blocks of code that perform a specific task. They allow you to organize your code, reduce duplication, and make it more modular and easier to maintain. Functions are defined using the def keyword, followed by the function name, parameters if any, and a colon. The function body is indented, and the function can return a value using the return statement. Python's extensive ecosystem of pre-built modules and libraries allows developers to quickly add powerful functionality to their programs without having to reinvent the wheel. Modules provide access to a wide range of specialized features, from data analysis and visualization to web development and machine learning, making Python a versatile language for diverse applications. The modular architecture of Python encourages code reuse and collaboration, as developers can easily share and integrate third-party libraries into their projects. Python's input function allows users to provide data for programs interactively. The print function is used to display output and information to the user. Python provides functions to read from and write to files, enabling persistent data storage. Python's socket module allows programs to send and receive data over a network. These input-output capabilities are fundamental for creating interactive and data-driven applications. String manipulation is a core part of working with text in Python. We'll start by looking at slicing and indexing, how to extract substrings and access individual characters. Strings can be sliced using square brackets, with a first character at index 0. This allows you to pull out just the parts of a string that you need. Python also has a large library of string methods for common text transformations. These include functions for things like converting case, searching and replacing, and splitting/joining strings. Finally, we'll cover f-strings, which make it easy to embed expressions directly into string literals. This allows you to seamlessly include variables and calculations in your output strings. Lists are mutable, ordered collections that allow you to store and manipulate data of different types. They're great when you need to add, remove, or rearrange elements. Tuples are immutable, ordered collections that can't be modified once created. Tuples are useful for representing fixed data structures like coordinates or database records. The key difference is that lists are mutable while tuples are immutable. Dictionaries are unordered collections of key-value pairs in Python. They allow you to store and retrieve data quickly by using unique keys. Dictionaries can store any combination of Python data types as both keys and values. This makes them highly versatile for representing complex data structures. The key-based access in dictionaries enables efficient lookups, updates, and deletions. This makes them optimal for applications that require rapid data retrieval. Dictionaries are widely used for tasks like tracking inventory, representing database records, and building recommendation systems. Their flexibility and performance make them a powerful data structure in Python. File I/O is a fundamental skill for any Python programmer. The open function allows you to read and write files. You can read the entire file or process it line by line. This enables you to work with data stored on disk. Key file operations include opening, closing, reading, writing, and appending. Python provides a variety of methods to handle these tasks. Being able to work with files is crucial for many real-world applications. Exceptions are errors that occur during program execution, disrupting the normal flow of the code. Python has a rich set of built-in exceptions that cover common programming errors. The try-except block allows you to handle exceptions gracefully, preventing your program from crashing. You can catch specific exceptions and take appropriate actions to recover or provide meaningful error messages. Object-oriented programming, or OOP, is a programming paradigm that organizes code into reusable objects with their own data and behaviors. OOP promotes modular design, where objects can be easily combined and reused, improving code organization and maintainability. Encapsulation is a key principle of OOP, allowing you to bundle data and functions into self-contained objects, hiding implementation details, and exposing only necessary interfaces. Inheritance enables objects to derive properties and methods from parent classes, enabling code sharing and hierarchical relationships between objects. Polymorphism allows objects of different classes to be treated as instances of a common superclass, providing flexibility and the ability to write more generic, adaptable code. Inheritance is a fundamental concept in object-oriented programming that allows new classes to be based on existing ones. Child classes inherit attributes and behaviors from parent classes, which promotes code reuse and the creation of class hierarchies. Polymorphism is another key OOP concept that enables objects of different classes to be treated as instances of a common superclass. This flexibility allows functions and methods to work with objects of various types, enhancing the modularity and extensibility of the code. Inheritance and polymorphism are powerful tools that enable developers to create more organized, maintainable, and scalable software systems. Python's datetime module provides classes to represent and work with dates, times, and time intervals. This simplifies common date and time operations in your programs. The datetime module includes support for time zones, enabling accurate handling of local times and time zone conversions. Python offers flexible date and time formatting, allowing you to convert between human-readable and machine-readable representations. Datetime objects can be easily compared, added, and subtracted, enabling date/time-based logic and calculations in your programs. Regular expressions, or regex, are a powerful pattern matching language that enable advanced string manipulation and search capabilities in Python. Regex allow you to define complex text patterns, which can be used to validate user input, extract data from text, and ensure consistency in your applications. With regex, you can easily replace, split, and modify text based on these patterns, streamlining a wide range of text processing tasks. Regex finds use cases in many areas of Python programming, such as web scraping, data cleaning, and log analysis, making them an essential tool in the Python programmer's toolkit. Web scraping with Python allows you to extract valuable data from websites. Python's libraries like Beautiful Soup make it easy to parse HTML and find the information you need. This opens up a world of data that can be automated and analyzed. Python can also handle the technical details of web navigation, making requests, following links, and respecting robots, txt. Once data is extracted, Python provides flexible options to store it, like CSV, Excel, or databases. This allows you to preserve and analyze the collected information. Python's socket module enables network communication, allowing for client-server architectures and distributed applications. Sockets provide a low-level interface to the TCP/IP protocol stack, giving developers control over network details like ports, addresses, and protocols. The socket module supports the creation of both client and server applications, enabling the building of networked programs like web servers, chat apps, and distributed systems. The Socket API allows for direct interaction with web protocols like HTTP and HTTPS, enabling the development of web scrapers, API clients, and custom web services. Multithreading in Python allows you to create and manage multiple threads of execution within a single program. This enables concurrent processing and can improve performance on multi-core systems. Concurrency introduces challenges like race conditions and deadlocks. Python provides synchronization primitives like locks, semaphores, and queues to coordinate access to shared resources and ensure thread-safe execution. The Asyncio module in Python enables asynchronous programming, allowing a single thread to handle multiple concurrent operations without blocking. This is crucial for building scalable network applications and I/O-bound programs. Decorators are a powerful tool in Python that allow you to extend or modify the behavior of functions without changing the original code. They are higher-order functions that can wrap other functions, adding new functionality or transforming the input-output. This makes decorators very flexible and reusable. You can apply the same decorator to multiple functions. Generators are a special type of function in Python that use the yield keyword instead of return. Generators don't return a full list all at once, but rather yield values one at a time. This makes generators memory efficient and well-suited for processing large or infinite data streams. We'll explore examples of both decorators and generators in the upcoming slides to see how they work in practice. Functional programming emphasizes the use of immutable data structures, where values cannot be changed after creation. This promotes referential transparency and simplifies reasoning about program behavior. Functions in functional programming are first-class citizens. They can be assigned to variables, passed as arguments, and returned from other functions. This enables the creation of higher-order functions that enhance code reuse and modularity. Functional programming follows a declarative style, focusing on what the program should do rather than how it should do it. This promotes clearer, more expressive code and facilitates parallel processing. Functional programming emphasizes the use of pure functions, which have no side effects and always return the same output for a given input. This simplifies testing and reasoning about program behavior. NumPy is the fundamental library for scientific computing in Python. It provides efficient multidimensional array objects and a vast collection of functions for working with these arrays. NumPy arrays enable high-performance element-wise operations, linear algebra, Fourier transforms, and a wide range of mathematical functions. This makes NumPy a powerful tool for numerical and scientific computing. NumPy is widely used in fields like physics, engineering, machine learning, and data analysis. It excels at handling large datasets, performing complex calculations, and integrating with other scientific Python libraries. Pandas is a powerful open-source Python library for data manipulation and analysis. It provides high-performance, easy-to-use data structures and data analysis tools. Pandas is great for working with structured, tabular, and time series data. Key features include robust data frames, advanced indexing, and a wide range of data cleaning and transformation functions. Pandas seamlessly integrates with other data science libraries like NumPy and Matplotlib. With Pandas, you can load, explore, pre-process, analyze, and visualize data all within a single workflow. Pandas' intuitive syntax and powerful data manipulation capabilities make it a go-to tool for data scientists and analysts. Matplotlib is a powerful and comprehensive library for creating high-quality 2D and 3D data visualizations in Python. It offers fine-grained control over every aspect of the visualization, from the plot type to the styling and formatting. Matplotlib integrates seamlessly with other data science libraries like Pandas, enabling the creation of interactive dashboards and data exploration tools. As a core component of the Python data science ecosystem, Matplotlib is widely used for visualizing results from machine learning models, statistical analyses, and other data-driven projects. Machine learning is the process of enabling computers to learn and improve from experience without being explicitly programmed. It involves developing algorithms that can analyze data and make predictions based on patterns and insights. This allows computers to perform tasks more effectively and efficiently without the need for manual programming. Python is a popular choice for building and deploying machine learning models due to its extensive libraries and tools like scikit-learn, TensorFlow, and PyTorch. Python's readability and flexibility make it well-suited for rapid prototyping and production-ready applications. Key machine learning techniques supported in Python include supervised learning, unsupervised learning, and deep learning. These techniques can be applied to a wide range of tasks like classification, regression, clustering, and natural language processing. Natural language processing, or NLP, is a field of artificial intelligence that focuses on understanding and processing human language. NLP begins by cleaning and preparing text data, removing noise, tokenizing words, and normalizing language. This is the text pre-processing stage. Next, NLP techniques are used to identify the grammatical role of each word, such as noun, verb, or adjective, to understand the structure of sentences. This is part of speech tagging. NLP can also extract and categorize key entities like people, organizations, locations, and other domain-specific concepts. This is called named entity recognition. Sentiment analysis is used to determine the emotional tone and polarity, whether the text is positive, negative, or neutral. Finally, text classification assigns text to predefined categories based on its content, enabling applications like spam detection and topic modeling. Python's web development frameworks like Flask and Django make it easy to create functional web applications. You can rapidly build prototypes, REST APIs, and dynamic websites using Python's readable syntax and extensive library support. Building a Python web app typically involves setting up a server, defining application logic, handling HTTP requests and responses, and rendering HTML templates. Python's batteries-included approach streamlines these tasks, allowing you to focus on your application's core features. Python's simplicity, flexibility, and powerful libraries make it an excellent choice for web development. Its robust standard library and wide range of third-party packages provide solutions for tasks like data processing, authentication, and database integration. Deploying Python applications is a multi-step process that involves packaging, hosting, configuring, deploying, and maintaining the application. First, you'll need to package your Python code, dependencies, and assets into a distributable package that can be easily deployed. Next, you'll need to choose a hosting platform. This could be a cloud platform, server, or container environment to run your application on. Once you've selected a hosting platform, you'll need to configure the runtime, dependencies, and any necessary configuration files to get your application up and running. After the deployment, you'll want to thoroughly test your application to ensure it's working as expected. Finally, you'll need to continuously monitor your application's performance and apply any necessary updates or maintenance to keep it running smoothly. Debugging and troubleshooting are key skills for any programmer. We'll cover the key steps in the debugging process. Identify the issue. Carefully examine your code, inputs, and outputs to pinpoint the source of the problem. Look for error messages, unexpected behavior, and relevant logs. Isolate the problem. Break down your code into smaller, testable components to narrow the scope and understand the root cause. Implement debugging techniques. Use Python's built-in tools like print statements, the debugger, and logging to step through your code and gather more information. Analyze and address. Once the issue is identified, apply your programming knowledge and problem-solving skills to fix the bug. This may involve correcting syntax errors, logical flaws, or addressing improper data handling. Virtual environments allow you to isolate project dependencies and avoid conflicts, creating self-contained Python installations with their own dependencies. The Python Package Index, PyPI, provides access to thousands of reusable packages, and tools like pip make it easy to install, upgrade, and remove packages. Python's package management system ensures compatibility and resolves dependencies, simplifying the process of adding third-party functionality to your projects. Virtual environments and requirements files allow you to recreate the exact same development setup across different machines, ensuring consistent and reliable deployments. Git allows you to save incremental changes to your project as commits, creating a detailed history of your code development. Branching lets you experiment with new features in isolation, while merging integrates those changes back into the main codebase. Git's distributed nature enables teams to work together effectively, with features like pull requests and remote repositories. The commit history provides a safety net, allowing you to easily revert mistakes or restore older versions of your code if needed. Continuous integration and deployment is a software development practice that automates the build, test, and deployment process. It starts with developers regularly committing code changes to a shared repository, which triggers the CI process. The CI system then automatically builds, tests, and packages the application to ensure code quality and consistency. With continuous deployment, the packaged application is automatically pushed to production servers, reducing manual effort and accelerating release cycles. Comprehensive monitoring and fast feedback loops allow for rapid issue detection and resolution, keeping the application healthy and up-to-date. The CI/CD pipeline enables an iterative, agile approach to development with frequent, incremental updates based on user feedback. Write clear, descriptive variable and function names to make your code easy to understand. Follow established naming conventions and code formatting standards for consistency. Break your program into smaller, reusable components like functions and classes. This promotes code organization, testability, and flexibility. Implement a version control system like Git to track changes, collaborate, and revert to previous states. Develop a robust suite of unit, integration, and end-to-end tests to catch bugs early. Ensure your code functions as expected and maintain quality over time. The goal of refactoring is to improve the quality and maintainability of your codebase. Identifying opportunities for refactoring is the first step. Look for areas with duplicated logic, complex conditionals, or poorly named variables. Refactoring should focus on improving readability and adhering to Python coding conventions. Analyze your code's efficiency and look for ways to optimize performance, such as eliminating unnecessary computations. Ensure your refactoring efforts don't introduce new bugs. Write comprehensive tests to validate the changes. Adopt a culture of continuous code improvement within your team, regularly reviewing and refining the codebase. Python's built-in Unitas module makes it easy to write automated tests for individual components of your code. These unit tests ensure your code functions correctly in isolation, catching bugs early in the development process. Integration testing focuses on how different parts of your application work together, verifying the integration of modules and overall system behavior. End-to-end testing simulates real-world user scenarios, validating the entire application workflow from start to finish in a production-like environment. Test-driven development, where you write tests first before implementing the actual code, promotes a more robust, maintainable, and bug-free design. Python's built-in profiling tools like cprofile and line_profiler provide detailed insights into performance bottlenecks by analyzing function call times, memory usage, and execution paths. Identifying these hotspots is the first step towards optimizing application performance. Various optimization techniques can then be applied, such as reducing unnecessary computations, using more efficient data structures, and parallelizing tasks to leverage multi-core systems. Applying these optimization strategies can significantly improve the overall performance of the application. Python is a powerful language for data science and analytics, with robust libraries and tools for data manipulation, predictive modeling, and visualization. The NumPy and Pandas libraries provide efficient data structures and functions for working with large, complex datasets, enabling advanced data preprocessing, analysis, and exploration. Python's machine learning ecosystem, including scikit-learn, TensorFlow, and PyTorch, allows data scientists to build, train, and deploy powerful predictive models for forecasting, classification, and clustering tasks. Matplotlib and other data visualization libraries integrate seamlessly with Python, enabling the creation of publication-quality plots, dashboards, and reports to communicate insights effectively. Python's OS and Shuttle modules provide powerful file automation capabilities, allowing you to easily copy, move, and delete files and directories. Python scripts can automate a wide range of system administration tasks, from managing user accounts to monitoring system logs and performing backups. Libraries like Selenium and ScrapePy enable Python to automate web interactions, from extracting data to filling out forms and testing web applications. The AP Scheduler library makes it simple to schedule and run Python scripts at specific intervals, making it ideal for automating recurring tasks. Python's web frameworks like Django and Flask provide a structured approach to building dynamic, scalable web applications. These frameworks handle common tasks like routing, templating, and database integration, allowing developers to focus on application logic. By leveraging Python's strengths in rapid prototyping and modular design, web developers can quickly create and deploy feature-rich websites and web services. Python is an excellent language for building web APIs, which are critical for powering modern web and mobile applications. Frameworks like Flask and FastAPI enable the creation of RESTful APIs that expose data and functionality to client applications. Python's strong data processing capabilities, combined with libraries like Requests and Erlib, simplify the task of consuming third-party APIs, integrating disparate systems, and building sophisticated, interconnected web applications. Python web applications can be seamlessly deployed to a variety of hosting environments, from cloud platforms to traditional web servers. Tools like Docker and Kubernetes make it easy to package and containerize Python apps for consistent, scalable, and reliable deployment. The rich ecosystem of Python tools and libraries also supports DevOps practices, enabling continuous integration, testing, and deployment workflows that accelerate the development and delivery of web applications. Python's simplicity and extensive libraries make it a great choice for quickly prototyping and iterating on game ideas. Robust Python-based game engines like Pygame and Pyglit provide powerful tools for building both 2D and 3D games. Python's cross-platform compatibility allows you to easily deploy your games on Windows, macOS, and Linux. Python's scientific computing libraries like NumPy and SciPy simplify implementing complex game mechanics like AI and physics. The active Python game development community offers a wealth of resources, libraries, and support to help you build great games. Python's ease of use and extensive library support make it a popular choice for IoT and embedded system development. These devices often need to collect data from a wide range of sensors, which Python's simplicity and rich ecosystem enable. Python can also be used to write firmware and control logic, allowing seamless integration with physical hardware. Its powerful data processing and machine learning capabilities make Python ideal for deploying intelligent analytics at the edge. Python's versatility enables smooth integration of IoT devices with cloud platforms for remote monitoring, data storage, and cloud-based services. Python is a dominant language in the rapidly growing global AI market, which is estimated to reach $100 billion by 2025. 90% of data scientists use Python for their machine learning and deep learning projects. Demand for Python skills in AI and data science roles has increased 6 times over the past 5 years. Python's simple syntax, vast ecosystem of libraries, and strong data manipulation capabilities make it a go-to language for artificial intelligence and machine learning. From training neural networks to deploying intelligent applications, Python is powering the next generation of AI-driven solutions across industries.